In the previous video, we've established that in order for us to truly understand this, we needed to understand the concept behind this, and now we need to understand the concept behind this. So in this video, we're going to try to understand the concept behind this thing here. Okay, so let's go back a few steps. So if you have two people, one of height h, a short person of height h, and then you have another taller person of height h2. If you get h1 plus h2 and then divided by 2, then this thing here represents the average of the two heights. So this would represent the average of the two heights. Now going back a few steps, back to the mean value theorem. If you have 2 points A here at A and at B here, then the gradient that exists between A and B is you doing this, the right angle triangle here. So the height here would be this bit, and then the across here would be this bit here. So the average gradient. So if you get this, if you get the height divided by the across here, it will give you the average gradient. So it's saying the average gradient, the average gradient that exists between the 2 points, or somewhere in between A and B, there exists a C somewhere where the gradient of the function equals the average gradient. We've seen this in the past. If you don't understand this bit here, then track down the mean value theorem. Okay, so along this concept here and along this concept here, we are going to now look at this. So if you have a square, let's say this square here. Okay, if you get the whole area, of the square, and then you divide it by this width here, then it will give you the height. Okay, or if you look at this area here, let's look at this rectangle here. If you get the area, the whole area of the rectangle, and then divide it by the width here, then it will give you this small height here. Okay, it will then give you this small height here. Well, now if you look at the area of this thing here, which is this bit here, by the way, and then divide it by the across here, then it will give you the average height of the function, if that makes sense. So if you get the whole area here, and then divide it by this here, then it will give you the average height of this whole function in between A and B. Okay, so if you have a function, let's say something like this, and then all of a sudden it jumps. If you have a function like this, so in between A and B, then the average height would be somewhere along here. The average height, the average height would be somewhere along here. Or if you have a function that's something like this. If you have a function looking something like this here, so in between A and B, then in between A and B, the average height would be somewhere around here. Well, so actually somewhere around here. Well, the point is that if you get the whole area and then you divide it by the width here, then it's going to give you the average height. Okay, so the average height here is given by you getting the whole area and then dividing it by the width here, and then that will then give you the average height of the function. Okay.